We're given this question. They said name x tends to 2. We have x squared minus 6x plus 2 over x squared plus x plus 9. So what do? We know when we're solving for limit, the first thing we are going to check is that we should substitute directly. So substituting x is equals to 2 into the given function, that what? X squared minus 6x plus 2 over what? Sorry, okay, we are substituting directly. That what? 2 square, right? And plus 2. Then we have what? 2 square plus x, okay, plus 2 plus 9, alright? And that will give us what? 2 squared is what? 4. 4 minus what? Minus 12 plus 2 over what? 4 plus 2 plus 9. So this will give us what? 4 minus 12. Okay, that will be minus 12 plus 2. That will be what? Minus 10. Then 4 minus 10 will give us what? Minus 6. Minus 6 over what? 4 plus 2 plus 9 will give us what? 15. I'll be minus 6 over 15. So we can break this down to the lowest term. So it will be what? 3 here what? 2. 3 here what? 5. That will be what? Minus 2 over 5. And that will be our final answer. Alright, let's take example 2. So they give us lim x tends to 2. X minus 2. Then in bracket x squared plus 3x minus 2 over what? X squared minus 4. So what do? Substituting directly into this given function, it's going to give us a 0 by 0, right? A 0 by 0. So what do? We can say that the denominator is what? We can use difference of 2 square for the denominator, all right? So if we are saying difference of 2 square says our a square minus b square with what? A minus b a plus b, all right? A minus b a plus b. So therefore we can now say that what? We can relate it to this. That what? X square minus what? Minus 2 square. That was x minus 2, right? X plus 2. Okay, so now we can input x minus 2x plus 2 into the given function. So that was x minus 2 in bracket x square plus 3x minus 2, all right, over what? X minus 2 x plus 2, right? So when we say this, we've inputted this into what? Into the given function. We can now cancel x minus 2, all right? So when x minus 2 cancel x minus 2, we have what? We are left with what? X squared plus 3x minus 2 over what? X plus 2. So now let's substitute 2 into the given function. So that what? 2 square, right, plus 3 minus 2 over what? 2 plus 2. And that will give us what? 2 square will be what? 4. That will be 4 plus 6, right, minus 2 over what? 2 plus 2. That's 4. So 4 plus 6 minus 2. That will be 6 minus 2 will give us what? 4. Then, okay, 4 plus 6 will be what? 10. Then 10 minus 2 will be what? 8. That will be 8 over what? Over 4. So 4 here what? 1. 4 here what? 2. So our final answer will be what? 2. Alright, our final. Alright, the next question, you are given this. They said lim x tends to infinity. Then what? Root x plus 1 minus 1 over what? Over x. So we know this. If we substitute infinity into it, we cannot work with that. Alright, it is an undefined or indeterminate function. Then what do? So since we see that we have a root here in the numerator, so we can use our idea of sort, and using our idea of sort we can rationalize. And when we say we want to rationalize, we take the conjugate of the what? Of the numerator in this case. All right, take the conjugate of the numerator. So in this case we take the conjugate. So rationalizing we have what? The conjugate will be what? Root x plus 1 plus 1, all right, root x plus 1 minus 1 over what? Over x, then multiply by what? Root x plus 1 plus 1 over what? Root x plus 1 plus 1. All right, so we have this. Now the idea of rationalization, when you rationalize, when you take the conjugate of the numerator, note we don't need to most cases we don't need to expand the denominator of the multiplication. We don't need to expand, so we only need to expand this numerator. All right, so we can say that what root x plus 1 minus 1 in brackets, then root x plus 1 plus 1 in bracket over what, over x open bracket root x plus 1 plus 1. All right, so therefore we have something like this. Now look at this numerator. We can also use the idea of what, of difference of 2 square. We can use it for this numerator here. All right, because we said difference of 2 square is what, a square minus b square is equals to what, a plus b, a minus b. So relating it to this, let our a be what, root x plus 1, and let our b be what, minus 1. So that will be what, root x plus 1 square, right, root x plus 1 square, then minus what, minus 1 square. Right, so that will give us what, this root will cancel what, this square will cancel what, the root. So and this will be what, minus 1. That will be what, x plus 1 minus 1, and that will give us what, x. That will be x. So we can now say that what, this numerator gives us what, x. So we can say that x over what, over x plus 1 plus 1. So therefore this x can cancel this x, so we are left with what, 1 over, that will be 1 over root x plus 1 plus 1. All right, so we can now impute infinity into this. So we can impute infinity into our given function. We can input infinity. That what, okay, that will be equals to 1 over root of infinity plus 1, all right, plus 1, and therefore this is equals to what, 0, because we have infinity. Infinity can be any number, so 1 divided by infinity is what, is 0. All right, so infinity can be any number. All right, so we don't know the number, so our answer will be what, 0. All right, so given this type of question on limit, we can see that this one is more of something that we can do. It is direct, so we can just say that what, 3 minus 3, all right, over what, over 6, and 3 minus 3 is what, 0 over 6, which is also what, 0. So this one is direct. We can substitute directly and get our answer. Right, so the next question, let's do. All right, so let's move to this question. So we're given lim x tends to 0, then root of what, 4 plus x minus 2 over what, over x. So when we substitute directly, it is 0, so we know it will give us an indefinite function, or I mean indeterminate function, or you either call it undefined function. So what can we do here? We can rationalize. So if we rationalize it, it will give us what, that what, lim, okay, so 4 plus x minus 2 over what, we know we multiply by the what, by the conjugate. We multiply the numerator and the denominator by the conjugate. That what will be the conjugate? Root 4 plus x, right, plus 2 over what, root 4 plus x plus 2. And also note that in the last question I said we don't need to expand what, the denominator. All right, so we can simply write what, 4, this one will give us what, 4 plus x. All right, the root will cancel root, then we'll pick 1 4 plus x, 4 plus x, then this will be what, all right, 4 plus x, then minus, okay, plus 2, right, root 4 plus x, all right, then what, minus 2 root 4 plus x, then minus 2 times plus 2 give us what, minus 4, right, over what, over x open bracket what, root 4 plus x, then plus 2, all right, root 4 plus x plus 2. So therefore we know that this one will cancel what, this one, then 4 we cancel what? Minus 4. So we are left with what? X over what? X over this. So we know this x can cancel this one here. That will be what? 1. So we are left with what? Alright, so that will be what? 1 over what? Root 4 plus x, then what? Plus 2. Alright, so 1 over root 4 plus x plus 2. So therefore, when we get it, we can now substitute x to be what? To be 0. That's what? 1 over root 4 plus 0, then plus 2. Right? That's what? 1 over root 4 plus 2. Right? So and we know root 4 is what? 2. That's what? 1 over 2 plus 2, which gives what? 1 over 4. And that will be our final answer. Alright. So given this type of question, right, so we know the first one we do when we solve for limit is that original standard we should substitute directly. All right, so when we substitute this directly, let's try it. That will give us what? They said x tends to y, so we are substituting x to what? To be y. So that will be what? Y raised power n minus what? Y raised power n over what? Y minus y. So that will be what? Y raised power n minus y raised power l will give us what? 0. Then y minus y is given us 0. All right, so therefore what do you do? So now we can move to the L'Hopital's rule. All right, let's move to the L'Hopital's rule. So L'Hopital's rule is just the normal differentiation. All right, so L'Hopital's rule. All right, L'Hopital's rule. So to use the L'Hopital's rule, we are going to differentiate with respect to what? With respect to x. So we are going to differentiate with respect to x. So when we differentiate with respect to x, that will give us what? Differentiate this x is power n with respect to x, it will give us what? Nx is power what? N minus 1. All right, and differentiate y is power n, because we are differentiating x, not y. All right, so this will give us what? 0. All right, over what? Differentiate for x here, that will be what? 1 minus what? Differentiate for x in y, it will be what? It will be 0, because we don't have any x variable here. That was 0 also. So that will be what? Nx is power n minus 1 over 1. All right, which is still what? Nx is power what? N minus 1. So therefore, we can now substitute y into the given function. We can substitute y as what? As x. That was what? Ny raised power what? Ny raised power n minus 1, and this will be our final answer. So that is how to solve this.